So question number 8 of the continuity. Fx equals to here modulus x upon x if x is not 0 and 0 if x is 0. What's the question? Find all points of discontinuities. That's the question. Now first what we notice, where the function change its values, that is at 0 then this, non-zero then this. So 0 is called here turning point. Now if x is not 0 in the solution here, if x is not 0, then function is modulus x upon x, being ratio of these two functions. Now what is this? This is the ratio of being ratio, or you can say division of two continuous functions. Two continuous functions is continuous. Why it is continuous? Again, yesterday we did, in the last session we did one result. If two functions are continuous, then their division is always a continuous. Now this is a division of which two functions? Modulus. It is always continuous if x is not 0. And here this x is a polynomial, or you can say that it's a linear function which is always continuous. So division of two continuous functions is a continuous function. Remember, here is a continuous function. So if x is not 0, there is no question. Now for x equals to 0, we check the continuity. For x equals to 0, we check the continuity. Now definition is here, formula for the function is about modulus, you see. And if you remember the definition of continuous function, if you have modulus, ceiling, box and inequality, you need to use right and left. So what we do here, we are checking continuity at 0. So we find f of 0, we find 0 from left and 0 from right, and we see whether these three are equal or not. Okay, so first I'll find f of 0. When x is 0, then what's the value of the function? It is 0. Remember, this is given to us. This is given. Okay. Now, because of modulus, we consider here limit from right first. Limit x tends to 0 from right of fx. Right. You just need to recall as I explained. Limit x tends to 0, here left of fx. So this is equals to limit x tends to 0 from right of fx. What is fx here? It is, I'll write x upon x. Why? Because x is greater than 0 here. X tends to 0 from right means x is greater than 0. So modulus x become x. Now this will get cancelled. So limit x tends to 0 from right of 1. And you know that the limit of constant is constant. So this is 1. So from this even you can conclude that, if I call this as 2 for example, you can conclude that the function is not continuous at 0. But still I'll do this. Here limit x tends to 0 from left. So x is less than 0. If x is less than 0, modulus x become minus x. I'll write here modulus x become minus x if x is less than 0. Right. This you know, here x is less than 0 because limit from left. So here this x will get cancelled. You are left with minus 1. And what's the limit of constant? It is a constant. This is 3. So from 1, 2 and 3. Actually no need to find these in the exam. This is just for your information I did. You can ignore this because first two limits were different. So from this you can say that function is not continuous at 0. What about other than 0? It is continuous. So you can say that f is continuous on every real number other than 0, or you can say that 0 is the point of discontinuity. So this way you can do the sums. Okay. Next I'll go to question number 12. The other are similar. So in the 12th question, you are given fx equals to x raised to 10 minus 1 if x is less than or equal to 1, x square if x is greater than 1. Now here again, which is a turning point? 1, remember. So first we check the continuity other than 1. But here you have less than, greater than. So we have mainly 3 possibilities. So in the solution here, if x is greater than 1, then what is fx here? Then fx is nothing but x raised to 10 minus 1. Fx is x raised to 10 minus 1. Now as it is a polynomial, you know, it is a standard polynomial function. As it is a polynomial function, therefore it is continuous. It is continuous function. Every polynomial is always continuous if x is greater than 1. If x is less than 1, then what about fx? Then fx is x squared. Oh, I'm sorry, greater than 1, then this is x squared. So let me write here less than 1. I'm sorry, please. If x is less than 1 here, then this. If x is greater than 1, let me correct this, I'm sorry. If x is greater than 1 here, this case, then fx is x squared. Great, this was less than 1. Less than 1, then polynomial. Okay, what about this? Again, x square, you know, it is quadratic and hence it is a polynomial. It is a polynomial function, and therefore it is continuous. Now you are left with only one possibility, that is equals to 1, which is a turning point. That is the only important point. Less than, more than, it's never important. So now if x is 1, this is called the turning point where function change its value. Okay, now again you go back. At 1 you have less than or equal to, greater than or equal to. So this is called inequality. Now if you have such inequality, then again we use right left concept. Remember, you know this. If you have such inequality, box function, ceiling function and modulus, then we use this right left concept. So we find f of 1, we find 1 from left, we find 1 from right. Okay, so first f of 1 as I explained. What is f of 1? Here f of 1 in this formula. So it will be 1 raised to 10 minus 1, which is 0, because 1 is included here. Remember, 1 is included here. Okay. Then next we find limit x tends to 1 from right of fx. 1 from right of fx. Okay, and what about the other one? Limit x tends to 1 from left of fx. Now what's the meaning of x tends to 1 from right? X is greater than 1, you know, from limit from right. If x is greater than 1, then which formula? X square. So you have limit x tends to 1 from right of x square. Put x equals to 1, so your answer will be 1 here. So from this 2, you can call this as 1, you can call this as 2. Directly from this, you can say that f is not continuous at which place? At 1. So therefore, you can say that the point of discontinuity is 1. At this place function is not continuous. What about the other points? Their function is continuous. Here it is continuous, here it is continuous, you see. Right? If you draw the graph of this function, you will find the break at 1. At the other point it would be continuous. Okay. Now this is not important here, but just for your reference I'll do it. This means x is less than 1. If x is less than 1, then you have which formula? X is less than 1, then we have this formula, x raised to 10 minus 1. Now apply the limit here. So 1 raised to 10, 1 minus 1, 0. Again, these three are different. But as in the beginning, you had noticed that this and this were different, so directly you can conclude this. In the exam, this is not necessary. This is just for your information I did. Question number 14 now. Their function is defined in this way. From 0 to 1, 3, 1, 2, 3, 4, and 3 to 10, 5. What are the turning points here? One turning point is 1. See, this is a turning point. Which is another turning point 3. So these are the main 2 points, remember. 3 and 1. Okay, so just for your reference, it would be like this. See, here 0, so it starts from 0. Then 1, here 1. Then 3, this, and then 3 to 10 here. So we have one case this 0 to 1, right, in the solution. There is nothing to remember from this to this, remember. So you can write here, for example, case number 1, for example, or possibility number 1, 0 less than or equal to x less than 1. 1 is turning point, so we are not including 1. Now 0 to 1, what is the function here? Fx equals to 3 is a constant function, you know. Constant function. Constant function means straight line function. It's a constant function. And constant means, you know, it's a horizontal line or a straight line. And every constant function is always continuous because it is a straight line. Therefore, here fx is continuous in this case. In which portion? This portion. Case number 2 now, that is now which portion? 1, 2, 3, this portion. 1 and 3 we are not taking, remember. 1 less than x less than 3, this portion, in this domain. Now in 1, 2, 3, what's the function here? Fx equals to 4 is a constant function, you know. And every constant function is always continuous, and therefore fx is continuous because it is a straight line function, so it's continuous. It's a standard function like polynomial function, Trago function. Case number 3, 3 to 10. So this is case number 3. That is x is from where to where? 3 to 10. 10 is ending point, so I've included 3. This turning point I have not included. See here, strict less than 3 or greater than 3. Okay, what about this case function? Again 5 is constant, is a constant function. And every constant function is like a polynomial or a straight line, and therefore fx is continuous. This is not a big task, just you have to write this much in the exam. Now, which points are important? These two, 3 and 1. These are called turning point, where the function change its value, 3 to 4. Here 4 to 5, so these are the turning points. So now we check the continuity at 3 and at 5. Now you have inequality in the definition. So again we need to use right left. So we use this again as we did in earlier 2 examples. We have inequality. Okay. So here now case number 4 I'll write. Case number 4 let me write. That is about at x equals to 1, remember. So first we find f of 1. Now what about f of 1? 1 is included here. So value of the function is 3. So f of 1 is 3. Now we get into limit x tends to 1 from right. You know now very well. Fx. Limit x tends to 1 from left of fx. The only thing you need to understand is x tends to 1 from right means x is greater than 1. If x is greater than 1, then you have which formula? X is greater than 1, then you have x is greater than 1, then the formula for the function is 4. Here x is more than 1. See this, we are concentrating here. X is 4, function is 4. So here fx is 4. There is a constant function, limit of a constant is constant. So here 4. Here it was 3, call this as 1. This is 4. So from this 2 you can say that, what we can say from this 2, f is not continuous at 1. No need to find this. You try. Here in exam this is not important. This is for you. Try what would be this. You can conclude directly from this. Not continuous at 1. Now where we are left? Next turning point, that is case number 5. That is at which place? At x equals to 3. So first we find f of 3. Another turning point. Where is f of 3? 3 is included here. So value of the function is 5. So this is 5. Now like this case, limit x tends to, you are checking at 3, remember 3 from right of fx. Here limit x tends to 3 from left of fx. What's the meaning of x tends to 3 from right? X is greater than 3. If x is greater than 3, what's the formula for function? If x is greater than 3, x is greater than 3, x is more than 3, formula for function is 5. So here fx will be 5. Limit x tends to 3 from right is 5. Limit of the constant is constant. These two are equal, so we need to calculate this, remember here. If these two were different, like this case, you could have concluded, but here it's not possible. Now what's the meaning of this? This means x is less than 3. If x is less than 3, then you have which formula? If x is less than 3, then you have formula for function equals to 4. So here it is 4. Limit of constant function, you know it's a constant. So here 4. This is 2. This is 3. So from 1, 2 and 3, you notice that these 3 are not equal. So function is not continuous at 3. It is not continuous at 1. It is not continuous at 3. So these are called points of discontinuities. Points of discontinuity. So you can write therefore f is continuous on every real number other than 1 and 3. Other than 1 and 3, remember. Continuous on R, because it was continuous on this. Sorry, here domain is not R. I'm sorry. Domain is from 0 to 10. Okay, so I should not write R here. I'm sorry. I should write close interval 0 to 10 minus 1, 2, 3. Please. This portion. I was thinking that it is about R, but it's not R. So f is continuous everywhere from 0 to 10, but other than these 2 points. So these are called points of discontinuities, remember. Okay, I hope you are fine with this. Next 70 number question is, you are given this function is continuous at 3. This is given to you, remember. The question is here, find the relation between A and B. This is the question. You will get one equation about A and B. What is the question? Find a relation about A and B. You mean get an equation about A and B. Now you are not going to check the continuity. You are already given that the function is continuous at 3. So in the solution here, I'll start in this way. Given that, this is given to us, given that f is here, f is continuous at 3. Now you have again inequality in the definition, so we need to use right left. So therefore limit x tends to 3 from right of fx. You get this, limit x tends to 3 from left of fx, and you get f of 3. Now you are not going to check whether they are equal or not. You are already given that this is continuous at 3, so all 3 must be equal. Remember, this is a definition. As it is continuous at 3, so all 3 must be same. Earlier you were checking whether it is a continuous or not, but here you are given that it is already continuous. So limit from right, limit from left equals to f of 3. Now what's the meaning of x tends to 3 from right? X is greater than 3. If x is greater than 3, which formula? This formula. So limit x tends to 3 from right here. X is greater than 3. So this formula bx plus 3 equals to limit x tends to 3 from left. So x is less than 3. X is less than 3, then which formula? Ax plus 1. Here x is less than 3. So this formula. At 3, 3 is included here. So put 3 here. What is f of 3? 3a plus 1. Again I repeat this. X tends to 3 from right. So x is greater than 3. Greater than 3, then which formula? This formula. So I place this. This means x is less than 3. Which formula? Ax plus 1. I place this. F of 3 means find the value of the function at 3. So it is here only. So I place 3 here. 3a plus 1. Now apply the limit. If I apply the limit here, this is 3b plus 3. If I apply the limit here, 3a plus 1, which is same as this. So here relation will be 3b minus 3a. If I take on the other side, minus 2. So you can write 3a minus 3b equals to 2. This is a relation. You can get relation like this. Take 3 on the left hand side. So minus 3a minus 2. Just taking minus common. 3a minus 3b equals to 2. This is a relation. Now next question is here, question number 18. You are given fx equals to lambda into x square minus 2x if x is less than or equal to 0, 4x plus 1 if x is greater than 0. You are also given that E is continuous at 0, remember. This is given. And what's the question? Question is find the lambda. This is a question. Get the value of lambda. This is the question here. Okay. So we want to find the lambda here. Now function is continuous at 0. So as I did here, you just have to write this much only. So therefore limit x tends to 0 from right, because you have inequality of fx, equals to limit x tends to 0 from left of fx equals to f of 0. Right? Now what is f of 0? 0 is included here. So I'll put 0 here. 0, 0. So this becomes 0. X tends to 0 from left. So here x is less than 0, remember. If x is less than 0, then which formula? This formula again. And I'll apply the limit. So if I apply the limit, this becomes 0. I have dropped one step, remember. X tends to 0 from right. So you have this formula here. X tends to 0 from right means what? X is greater than 0. If x is greater than 0, then which formula? 4x plus 1. So you put 4x plus 1. Limit x tends to 0 from right. Here 4x plus 1. You apply the limit. So we'll get the here 1. 1 equals to 0. Now this is not possible. Is not possible. What's the meaning of this? That means there is no lambda for which this become continuous. This is always discontinuous. Therefore you can write there is no lambda. There is no lambda for which there is no lambda for which f is continuous at 0. Because 1 equals to 0, that means these two never be equal. That means function never be continuous. So you can say that there is no lambda for which function is continuous at 0. I mean function is never continuous 0 here. The next question, 19 number, you are given function gx equals to x minus box of x. Box function you know very well. First integer from left side. We show that gx is discontinuous at all integral points. Integral points means integer points, remember. So what I'll do, I'll take one integer. So for any, let's take n from z. Integral means integer point. So what I did, I have taken small n from z. So here n is any integral value, and we check continuity. We check continuity. Oh sorry, we are not going to check. We want to prove here. We'll show that at this point function is discontinuous. That we want to show. So we are not going to check here. We'll prove that it is discontinuous at every n belongs to z. Now box function is involved, so you know very well you need to consider right, left and f of n. So first we find f of n. What is f of n? N minus box of n. What's a box of n? It would be n only. For any integer, box value is that number, so 0. Call this as 1. Now we go to limit x tends to, remember you are checking continuity at n, so n from right of fx. Here limit x tends to n from left of fx, gx here. Function g you are given. Okay. So I'm sorry, here also I should write g of n, remember. Okay. So now what is the meaning of x tends to n from right? X is greater than n. Okay. So it's like this diagram, remember. Suppose this is n. The value of x is somewhere here. X is greater than n, somewhere here. So suppose if this is 2, for example, then 2.1, 2.3, something like this. And what's the box value in this case? So box value of x in this case would be n only, remember. So here limit, this is the only point you need to understand here. X tends to n from right. What is g of x? That is x minus box of x. So this is n and box of x is also n. So n minus n is 0. I have applied the limit. This is n and box of x is n here. So this is 0. So these two are equal. Now here x is less than n. X is less than n here, remember. You just have a look here. N, values of x is somewhere here. Suppose this is, for example, I assume this as 2. Then this is 1.9, 1.8, 1.5. So what is the box value? Previous integer. Now which is a previous integer here? N minus 1. So box of x would be here n minus 1, remember. So what happens here to the function? Limit x tends to n from left. Function gx is x minus, what's the box of x? That is n minus 1. In the previous case, box of x was n, remember. So I wrote n here. And x as tends to n, this is n. Now internally if you apply the limit, here n minus n plus 1. So this will get cancelled, this is 1. I hope this is clear to you. I repeat this portion. You are asked to check at every integral function is discontinuous. So what I did, integral values means integer values. What I did, I've taken any n from z. And at this n, here it is integer, we show that the function is discontinuous. Now you know if you have box function in the definition, you need to use right left. So first I obtain g of n. What's the g of n? N minus box of n. For any integer, box value is itself. So this is 0. Go for limit from right here. What's the meaning of limit x tends to n from right? X is more than n. So values of x are more than n. Just for understanding, if I take n equals to 2 for example, then 2.1, 2.2, 2.3, these are the values of x. You put into the box function. What's the box of 2.1, 2.2, 2.5 and so on? It is 2, that is here n. First integer from left side, so your left hand side integer is n, so box value is n. So function will be x minus, if you want you can write here n also. So now if we apply the limit n minus n, which is 0, go to limit x tends to n from left, so x is less than n, that is this side. Now if you have x this side, which is the first integer from left side, first integer from left side is n minus 1, so box value is n minus 1, which are placed in the formula of the function here. So this is n minus 1, you apply the limit here, so n, and if you open the bracket this become 1, so this is 1. So from 1, 2 and 3, you see that they are not equal. From 1, 2 and 3, function g, that is this, is discontinuous at each n belongs to z. Each n belongs to z. So this is the solution.